So let's get started. Our agenda for today is going to be very simple. Just we're going to stick to the topic, the title that we discussed. We'll first understand the problem around cost efficiencies, cost solutions, credit consumption basically. Then Pradeep will explain us, like from the PM perspective, how we actually optimize our cost, how do we make it better. We'll learn some optimization techniques where we'll learn how do you make your queries better, what are the best approaches you should be choosing, which is the right one, and how you can save some credits, how you can minimize credit consumption. Okay, and then further in the last, towards the end, we'll see the solution as well, what exactly you can use for credit consumption. We'll be also sharing some resources with you all towards the end of the session that you can find helpful, and we'll try to share the deck as well. We'll update the same post. So let's get started. We are all aware about the agentic enterprise, and we are living in the AI era for sure. When it comes to Data 360, so Data 360 is something that fuels your agent force or fuels your AI. For any AI agent to run accurately or to give you best responses, you need data, right? And that's where Data 360 comes into picture. So this whole agentic enterprise, I'm sure you have seen it at a lot of places. And when you're feeding in information to the system, this information has been coming up from a lot of places. You're getting in data, you're sending out information, you get processing information as well. So a lot of computation is going around behind the scenes. You're building your solutions, you're building your use cases, but how do we make this all optimized? How do we save our cost, or how do we build sustainably with Data 360? That's the thing that we're going to learn today. So let's understand the current problems, current consumption problems that we have all been facing. So as a developer, I would say that even before you start building something, before you start building your flow or Data 360 CI or anything basically, first the rule number one would be understand your credit. You need to understand your credit consumption, because there is no console as such which will give you credit consumption right away. So if you have a streaming CI that is running, that is processing millions of record, you're going to know about it, like the credits consumed only when you get your invoice and not in your console. And that's the reason it's quite important to optimize the way you're building things. One single query can lead you to a extremely high invoice, right? And that's not what you want. You do not want the awkward conversations. So let's first understand the credit consumption, how it all works. So first we have the three credit consumption. We have credit consumption query, there is data storage and TBs. So there are different components, there are different consumption components, and we'll see how we can minimize them. Okay, so this is the dream versus reality. And we actually call it as production crisis. This is what we have been getting from customers. So most of the customers, they are halfway through their credit and they are already out of the credit that they have been assigned for or they have requested for. And this is something that we have been getting for customer, that how do we optimize our credit? Because one thing about Data 360 is, if you're on zero credit, it won't stop working. It will still run, it will keep running, your CIs will keep running, your processes will keep running, and you will get to know about it only when you get your invoice. So that's gonna hit you hard for sure, and we don't want that for sure. So how do we minimize this? How do we optimize it? And before going into the solution that will be given to us by Pradeep, let us also understand why does this exactly happens. So as Salesforce developers, Salesforce users, we are not used to this consumption-based model, okay? When we have been dealing with Salesforce, we are already aware what we are paying for. We already choose the set of stuff, sandboxes or limits, and then we are using within the limit. But it's not the same with Data 360. You're first going ahead, you're using it as per your pay-as-you-go basis or consumption basis. And that's the reason we're treating it as a black box. We are not sure how our credits are being burned, where it has been, what's going wrong exactly, whether it is with some testing that's gone wrong, or if it's a wrong SQL query or a wrong process. We are also not sure which approach would be the right for us to use. So one small design mistake or a scheduled job that which is badly scheduled, or maybe if you're running it per hour, or a bad SQL query or bad query could actually result, well, lead you to spend more dollars. And the mistake that you do in the first step is going to grow exponentially. We'll also see how. So if you see all these 3 stages, rocket 1, rocket 2, rocket 3, I would say there are like, these are 3 phases, I mean the main phases, when you're congesting, you're connecting your data, you're harmonizing, you're activating your data. So one step in the first one will act as a multiplier. And that's going to grow exponentially, costing you a fortune maybe towards the end. So Pradeep will explain us more how we can find a solution and how we can take it ahead.
Sure. Thanks, Akshata. So basically, at the beginning, we spoke about the 3 consumption metrics. You buy a product, you have to pay for it. You buy a data space or any application for that matter, you have to pay for the SKU. That's more predictive. You can plan ahead in time. But there are 2 things, variable costs, that you cannot predict for. One is the processing cost and storage cost. It's just a function of the data volume that you want to use. So I'm going to focus purely on the consumption of the processing. Fortunately, I'm going to talk about all the things that you can do right off the bat today. Nothing futuristic, nothing that is there in the roadmap. All that is available today is just a matter of the informing you to educating you so that you can use it in your organization. So like I said, in any kind of data system that you have used, including Data 360, is nothing different here. First, you need to bring the data in. You connect the data, bring the data in as data stream, DLO, and the likes of that, be it structured or unstructured. And then the raw data is generally not going to be useful. You have to make sense of the data. So generally you transform the data to either harmonizing it into a DMO, or you build some insights or metrics, whatnot. And finally, what we call activate. In this case, I don't mean a marketing activation. I mean like activating the data in terms of using the data for whatever purposes, either to generate your business insights or powering your CRM applications, to analytics, to agents, anything, or marketing activation. For that matter, anything that we call is activation, that's purely a query layer. So before I jump on to that, I just wanted to call out that it's very clearly documented in Data 360 documentation. The consumption is calculated in terms of rows processed. It's just a function of rows exist, the storage exists. It's not the number of rows that's an output. What that basically means is, if you got 1 million profiles or 1 million orders, and finally you look up a particular order by order ID, if you have not stored the data properly, if you have not queried the data properly, and you read 1 million rows and finally publish 1 row for in the output transform, you are charged for 1 million rows, not for 1 row, right? It's what we call a pre-filter rows, not post-filter. So that's something you have to understand. The second thing is, a very common mistake that people do is they replicate the data too many times, right? When you take a sandbox, you take a full copy, you want to run the entire testing suite because you're building the Data 360 implementation, everything gets accounted the same way. There is no special rate card for sandbox versus production org. So if the more data that you process, the more consumption that accrues. So one recommendation is always to make sure what kind of data that you are testing. Do you need the same amount of volume in your sandbox when you are developing it, rather than doing everything on the production. There are use cases where you want to do the entire thing on production, like training a model and all those things, because you cannot do it on synthetic model, which is completely acceptable. But wherever possible, try to minimize the amount of data. We'll cover that in a bit. All right. So this is some stats that we pulled from across all the Data 360 tenants, right? The first graph, on the one on the left hand side, shows the rows processed by what kind of process it is, right? If you see, data queries compounds for almost 50% of the rows processed, be it for ingestion, be it for processing, or be it for activation, which is a kind of expected. Segment and activation and data queries all together account for almost 99% of the rows processed across all the Data 360 tenants that we have seen. That's one of the expected lines. You store the data once, you process the data once, but you use it again and again, right? Nothing different about it. The second is a different view. It shows the amount of jobs that have been run, right? The jobs are basically what the intermediate layer are. It could be ingestion and processing, not so much on the usage side. It's how much of the data is being processed, not in terms of the rows, but in terms of the jobs that are run. As expected, transform seems to be the highest. Almost 95% of the jobs are there. ingestion and other activities account for remaining 5%. The reason I wanted to bring this up is you have to know for your org where the rows are getting processed, what are the components that are getting processed, and naturally focus on that. It's pretty obvious. All right. Let's talk about the 3 stages: getting the data in, processing, and activation. Let's start with getting the data in. Before you get the data in, before you make a choice on how to get the data in, you have to figure out what's the business problem, where is the data getting stored, and what's the right way to get that data in. There is a good old standard ingestion route where the data gets replicated from source to the data lake, right? And zero copy is a new phenomena that Salesforce pioneered in the last few years along with AWS, Databricks, Azure, and few other hyperscalers. And the plan is to extend it to other connectors. What zero copy does is it doesn't move the data. Our philosophy in zero copy is the best way to move the data is not to move the data. So one of the things we recommend people is figure out what are the requirements, how frequently do you need to access the data. If you need to access the data again and again, we recommend ingestion, keeping aside all the factors aside, because you store the data once and then do it. I'll come to that details in a bit. But if you need to access the data rarely, but you want to access it from the surface layer of CRM, zero copy is the best way in terms of cost and other things. The other requirement is generally localization. There are regulations across Europe and US and other countries where the data is required not to be moved across geos. In such cases, zero copy is the best way because you don't move the data, you just query the data and surface the data. You don't actually physically move the data. But if data copies are acceptable, then standard ingestion is the way to go. One of the things that you have to understand about standard ingestion is a one-time ingestion cost but multiple query cost. On the other hand, in the case of zero copy, the cost is incurred on every query. You have to pay it on data 360 because you have to store it, bring it to data 360, there's a network traffic, and also on the hyperscaler where the source data is there. So if you are using say Azure or Databricks, Azure and Databricks will charge you for the amount of data that you are transferring, and data 360 will also charge you because that's the number of rows that you have processed. Of course, you can reduce it in certain cases by acceleration, but I'll come to acceleration in a bit. Yeah. So let's come to streaming ingestion, the standard ingestion routes, right? There are two again optimizations that you can do. There's something called batch and streaming, right? So streaming is relatively 3 to 5 times more expensive than batch. Streaming ingestion is a way where the source sends a push event to the data 360. Just to give you an example, ingestion API, web SDK, event bus ingestion, Kafka ingestion, all that are basically what you call push architectures where somebody is telling me this is what got changed and please process it. And data 360 can read it from it, get into Lakehouse and process it. On the other hand, the batch ingestion is where our connectors, JDBC connectors and the likes of that, we connect to the source, we pull the data. The batch ingestion is generally scheduled. It can go from few minutes to days and weeks, right? You can configure a schedule. So the recommendation is always figure out what is the need of data freshness. If you don't need real time, please don't pursue real time because it's going to be expensive for you. It also depends on the kind of source. Some sources do not have push event architecture, so naturally you can't do that. That's a limitation of technology, but keeping that aside, functionally, wherever possible, use batch ingestion. Like I said, streaming ingestion is much more expensive than batch. The other thing you have to also consider is just because the source produces change events, you can always use a lot of open source technologies to produce, for example, from AWS sources, you can use systems to produce change events. There are a lot of technologies that can read the physical data and produce change events. You have to also consider the nature of the transactions that happen on the source. Streaming ingestion works best when the data is constant traffic and not having like data bursts. If you have large processing like on the weekday or due to some database transactions and the data burst, streaming ingestion is going to be very expensive. If the transactions change very frequently, streaming ingestion is going to be expensive. A common example in one of my older experiences, somebody added an index on the source. The adding an index or adding a column on the source, a new column, literally goes and updates the default value for all the historical records, a billion records. And a billion streaming events came in, the whole ingestion pipeline crashed, and it took like 4 days to recover the data. So it's very critical that you understand not the just the requirement of the SLA requirement, but also the nature of the transactions that can happen on the source. If there's a data burst, streaming ingestion can be very problematic in terms of the cost and also in terms of the latency, because it will take like days and weeks, assuming there is no data loss, to catch up. So we have to be very cognizant of the fact. So a typical case for streaming ingestion, just to give for those of you who are new, is typically if you want to visit how many people are visiting your websites. It's a real-time requirement. You need to know how many people are logged on to your website. You want to send a promotion to the visitors who are visiting your website right then and there. It absolutely makes sense. If your requirement says, hey, I'm acceptable with a 1 hour delay, I'm acceptable with a weekly delay, I care about the trend and not the absolute third decimal place, please use batch wherever possible, be it for ingestion. And another critical factor, the moment you've gone to batch, you can never come back to streaming. I hope you, any downstream batch and always be in terms of batch. There is no point running a streaming CIA on a batch ingestion module, right? All right, so just wanted to also cover the zero copy. Zero copy is, like I said, is a new benchmark of ingestion where we are saying we don't want to move the data from the source, but we have got two technologies. We started with something called query federation. Just to give a quick introduction of what is query federation. Any query that you do on the DC SQL on the source gets translated to the source SQL, be it JDBC or be it whatever the hyperscaler provides. So query to query translation occurs and we bring the data in. It works great wherever the query translation works and subject to certain limitations. And naturally, as you can expect, there's an amount of hops that are adding is too much, right? There's a DC SQL and then there's a query SQL translation to the hyperscaler or the source SQL, and then you bring the data in. On the other hand, in the file federation architecture, the DC SQL directly goes to the physical layer of the source that you support. So you are completely avoiding one query layer on the source side. So we are bypassing that completely. So because in the query federation there's a bottleneck happening on two kinds of translation, it's slightly slower. Of course, you can make it faster with something called acceleration where we cache local amount of data. But file federation is much faster because you are bypassing a lot of query layers. Query federation cost is high because you have to pay both on the source and the data 360 side because the data is processed twice. On the other hand, file federation cost is much lesser. You just have to pay for the query on the data 360 and data transfer on the source. You don't have to pay for the query cost. Query federation is also better for relatively lower volume of records because every time you have to access it from the source. File federation can handle much better because you are accessing the file system directly. So once you get the connect to the source, this is on the standard ingestion size, you have to either physically store the data or at least represent the DLO in a particular format, right? When you configure a DLO, which is the system of record for us, or the raw data, there is something called category that came from the CDP world. We call it profile or others. In both the cases, it's stored by primary key. And for each profile or others, you can have engagement data. Profile is generally used for things like contact, lead, and account where you want to do an IR and you want to build. So think about like a dimension on which you want to, it's a unit against which you want to have some insights generated. The way internally it works is hash based on the primary key. So naturally it's optimized for primary key lookups, right? On the other hand, engagement is a time-based activity. It's generally time-based activity like website activity, visits, orders, and the likes of that. And whenever you create an engagement, there's something called a property that you have set at the time of authoring the DLO, where we say, hey, what is that event time column? So you can have multiple time-based columns. You can select whatever appropriate. So that is a column that we use for partitioning the data. It's generally stored in 1 hour and 24 and weekly and all those things. We do a compaction and store it. The reason we do that is as a consequence of this partition, it's optimized for time-based queries. So if you say, hey, last 3 months, last 6 months, last 9 months, it works great. If you try to do a primary key, it doesn't work. One common factor we have seen is people use a wrong date time column. If you use a wrong date time column, the data gets stored multiple times. It gets stored across partitions. It simply doesn't work. If you use, for example, a common example is website activity. It's generally, it has like time at which activity gets created. It's a great event time column for storing. But we have seen in certain cases like cases and orders get updated. Don't use a modified timestamp. The problem with storing modified timestamp is the same order data gets replicated multiple times in each partition. There is no way to fix it. So your queries ingestion becomes heavy, the records gets duplicated, and processing naturally is a second order effect of that. Naturally, lastly we built something called a secondary index. So as I illustrated a few minutes back, engagement is great for time-based lookups, but you can't do primary key. But there are other use cases where we want to do a lookup on. We release something called a secondary index. Secondary index works on like any primary index. It works great for high cardinality columns like ID, name, phone number, which has relatively few records matching that. That's what we call high cardinality. It's also available for data graph and things like that, where you want to immediately get a view of an individual account and other things. You can do a quick lookup from data cloud via query. Avoid enumerized Boolean kind of columns, yes, no kind of columns, because the B tree that gets built behind the screen has a very high distribution and you don't get any efficiencies. All right. So like I said, we talked about connecting the data. Let's talk about harmonizing, which we call data processing and making sense of all the data. First thing, reduce the data volume and scope. How do we do that? Streamline your data, don't ingest the data, don't process the data that you don't care about. Remove irrelevant records, remove stale records, remove null records. There are a lot of columns that you don't care. Please ignore them. If you don't care the data points, please ignore them in the transform CI and whatever other things. The second thing is sort and limits, right? So sort and limits actually works where you can cap the number of records, right? Like number of, for example, in a data graph, do you care about last 3 years of orders? Probably not. What you care about is last 1 week of record. That's what the customer cares about. The older orders would have been shipped. You don't have in progress. Customers care about, for example, in transit orders. When is my order coming? What's happening to my last transfer? What happened to my recent open applications? Think about open opportunities and open leads and things like that. You don't care about the things that are already done and dusted. Third thing, relevant nodes. If you don't care about a column and attribute, please don't use it. The more amount of columns horizontally you add, the more amount of data transfer that occurs. From a row processing point of view, Data 360 will not charge you more, but if you are using zero copy and other things, the amount of data transfer naturally increases. Similarly, the other element of harmonizing data is use efficient joins. I'll give an example of that. How many of you are aware of what you call qualified keys that we introduced few years back? All right, you are aware? Fairly good. So just to give an example, a primary key everybody understands is a unique ID for a record. You bring the data in, but Data 360 is, like I said, you can bring the data from CRM, non-CRM external sources. You may have different channels where the same amount, similar logical data exists, and when you harmonize, the keys may conflict. Given a simple example is, you get a order data, maybe you got orders from US, UK, and maybe whatever country you support. The order ID, if the database is different, the order primary keys can conflict. So to avoid the primary key, we introduce something called a qualified key, where you can annotate it, enrich it, to create something like a composite key to provide key conflicts and record conflicts and get a distinct record. It's very critical if you want to use an IR and things like that. So that's basically the primary key that we use behind the scene. So one recommendation, just don't use the primary key that you have declared. Use what you call fully qualified key. If you go to any DLO, you will see something called a qualified key. Use that. That's actually much better relationship. That's the actual true primary key. The second thing is, the more amount of joins that you do, the more amount of processing that occurs. Avoid too many joins, avoid deep relationships. If you can navigate through one relationship, prefer that rather than going through multiple relationships. So creating a DMO relationship is extremely critical in short. Data skew. it's very critical. If some records have a bulk of the data volume, handle them separately. Trying to bring all the data in will become processing on the processing side. So handle single key joins separately. There are normalize values. If you got certain values that you set it as default, normalize the values like NA, unknown and all those things, they are inefficient, make them null or set them to something so that the data type is properly set and processing becomes better. This is probably one of the most fundamental things that you can do. You try to compress all your business logic into one massive transform as CI. Please modularize that. Generally, there are, like I said, the nature of the data is different for different things. The way the order data volumes are different, the way the profile changes, the way opportunity amount changes, the way other data types change is very different. Trying to combine them in everything will force you to the worst amount of data, right? So if you modularize that, what you can possibly do is segregate the data that moves slowly, slow moving dimensions versus the fast moving metrics, and then you can combine them if you want to aggregate them. Having prefer smaller components over one massive one. The secondly, in terms of refresh rate, it's very obvious. If you need the data once a week, ingest process once a week, don't try to do it on an hourly basis. Lastly, there are some soft size limits that we have recommended here. I have given an example of data graph and data prep. So the size increases, the processing becomes slower, the SLA gets translated in terms of memory efficiency and storage and optimization, you lose the benefits. All right, this is just an example of something that we did in SDM and calculated insight, but you can take this as a general thing when you are building a dashboard or whatever. The CI, the way it works is it runs its job, computes it and stores the results. On the other hand, semantic data model does it everything at runtime, at query time. It computes everything on the fly. Use CI wherever shorter latency is required because it does less processing at query time. Naturally, the amount of rows processed, the row amount of lookup time, everything is reduced. Semantic data model, though it works great, freshness is important. You care about accuracy of the data, but longer latency is acceptable. So imagine total number of orders that you do. You can do it at runtime, total number of orders in the last 6 months, or you can calculate total number of orders as a CI and store it. The total number of orders more or less will be different. Do you care about the total number of orders at real time, like what happened up to the last minute? Then use SDM. If you care about total number of orders like a trend on time series, CI is better. Total number of orders will query all the total number of orders if you use an SDM at every point you do the query. If you build a dashboard on SDM and try to do the total number of orders that I am seeing, you literally scan it every time somebody opens the dashboard. On the other hand, CI computes once, you get the one row from a CI, that's it, you get charged for one row. So be aware of the difference. So CI is better when you want a repeat query and repeat usage, cost wise better, stillness is acceptable up to a certain point of time, so SDM works other way. I have given the cost profile there. CI is one-time cost of compute, low excess cost. SDM has low storage, literally zero storage. Sure, metadata storage is there, but we don't charge for that. But very high query compute cost. And lastly, I am running short of time, so I'll try to speed up. Activate is basically query. At the end of the day, everything that you do in segmentation or activation or query or external access, you query the data. Avoid accessing all the columns. I just described avoiding unnecessary nodes. Good joins, use primary key, preferably the fully qualified primary key. One pro tip, if you have a zero copy table which is federated and you have a local table from CRM which is batch ingested, the query federation doesn't work great in terms of query push down. What query push down is basically if you put a cross filter or you try to use a join, because you are accessing two different systems, query push down doesn't work. If the query push down or predicate push down doesn't work, you basically fall back to what you call table scan. You literally have to scan every record to find the relevant records and you get a subset of the records and output. So query push down breaks down with query federation if you try to mix a local table and a zero copy table. Naturally, update the refresh, be it segmentation, be it analytics, be it SDM, optimize it according to your requirements. Don't try to do faster, because faster is not always better. Some of the observations: table scans, use filters, appropriate filters. Using filter on the partition column, which is the date time, works. If you use it on any other column, it doesn't work. Look up on a primary key doesn't work if there is no secondary index. Like I said, be aware of what kind of where clause works. Some of the queries like not clause and not equals and not something and likes and of the world, no query system can understand that, because it cannot go and look up the record. It does a table scan, filters it, and retrieves the only thing. So avoid query patterns that does a table scan. Pro tip: wherever possible, pre-process the data. Just like I gave the example of SDM versus CI, data graph is a great example. Data graph computes the story, gets an aggregate, store it, and use it for whatever in the time of agentic or wherever fast responses are there. Again, use joins. Everybody knows joins are better than implicit joins. Avoid scalar subqueries, because it accesses the same inner query, inner table again and again for each source table. Use small table to large table lookup, so that the number of cross Cartesian join gets reduced. Lastly, I hope you are aware that V3 version of the data DC SQL has been released. It provides a better dialect now. It better filter and predicate push down, so the number of queries, so the number of rows processed is much lesser. It also supports secondary indexing, it supports caching, so that the rows processed gets reduced. Yeah, that brings me to digital wallet.
Thank you so much.
Back to you, Akshata. Yes. Thank you.
Awesome. So that was quite informative. I'm sure you must have felt overwhelmed as well, but don't worry, this is recorded. You have the photos. And thank you again, because it was informative for me as well. It was like, wow, there are so many queries, so many best practices that definitely we can follow. But once you're done following all of this solution that Pradeep has provided us, how do we make sure that we are still tracking the credit consumption? Back to point one, the rule number one, that always before you start building, please make sure your credit consumption, what credits you have, what are the availability of credits. So digital wallet is the best way. But digital wallet, you can get a track of your credit consumptions. It is refreshed every 4 hours. You will get a whole dashboard, basically a whole portfolio of how much credits you have used, how much you have consumed, how much you are yet to consume. And not just that, you can also set threshold limits, like 50% of your threshold credit, 75%, 80%. So you are already notified about the credit consumption. So this is something that's available, and I just learned today from Pradeep that yeah, it's available for free as well. I mean, you just need to use it, because there is no other dashboard that will give you insights. All right, moving ahead. Okay, so here are some key takeaways from our entire session. Like, how do we actually understand? Like, we have understood the problem first of all. Okay, like what exactly credit consumption is. Why we are facing what is the black box problem that we're facing with data 360, because we are not aware about our credits, we're not aware about credit consumptions. Then we have seen all the best options, all the best possible methods in different stages of connecting data, activating, and throughout the entire life cycle. How do we make the best of it? How do we build an optimal solution? And then you have also studied about the digital wallet, which can be used to further keep a track of your credits that you're using and to keep your cost low. So how to build a cost efficient solution in a particular way, we have just given a 40-minute thing. Okay, and here are some resources. Let me just, okay, this thing doesn't work. All right, here are some resources that Trailhead post, and y'all can let us know. I mean, if we come across more resources, we'll keep adding on the same post, maybe in the comments, or we'll edit the post. Yeah, I hope you found this helpful, and if you did, let us know by your feedback. Your feedback is actually a gift for us. Let us know how we did with the session, the entire cost consumption mechanics. And with that, thank you so much for joining us again today. I hope you had a great TDX and great travels back home.